All right, really quick common mistakes video about Lab 5. This is going to be really quick because I think of all the labs, this one has gone historically the best for students, so kind of a nice note to end on. As always, I give you the instructions here. You want to make sure you read through those. Here's the data that we'll be dealing with in this problem. And all of your work will be over here on the Analysis tab. You're supposed to identify the explanatory and response variables, and then make a scatter plot, and then add an LSR line to this scatter plot. Maybe I should put that up here. It's specified in the Instructions tab in step 2. Once you have that LSR line, you can answer all these questions down here. Note that there's a hint for this second one because this second one's a little bit tricky. More on that in just a sec. But the comment that I want to make is all of this stuff might feel a little bit foreign because you're in Excel, but it's really not. It's similar to what you've been doing on the homework and the classwork. So I opened up classwork 18 and just go to the first question, although really it doesn't matter which one. We have our data set here, very similar to how we have a data set here. And then going back over to the classwork, we do a whole bunch of analysis, determine explanatory and response variables, make a scatter plot, add an LSR line to your scatter plot, make predictions, interpret the coefficients, calculate the correlation coefficient and the coefficient of determination, and then interpret those things. I said those all pretty quickly, but I think those things are all that you are asked to do here in the Analysis tab. What is the value of the coefficient of determination in your chart? Coefficient of determination was asked about in this classwork. Here it is down here on part, L, I guess. If you don't remember that the coefficient of determination is r squared, it's told to you in this problem here. The next thing you're asked about is about the correlation coefficient, which is r. Typically, when you're doing your homework, your calculator will tell you r and r squared directly, so these are pretty easy to figure out. On the lab, it's a little bit different. You get r squared from your chart here. If you follow the instructions in this tab, on step 2, you can display your trend line and display r squared on the chart itself. So if all goes well, you'll get r squared from up here, and then you can figure out r, because r is the square root of r squared. But be a little bit careful, as this note says here. It's not just the square root. You'll have to figure out whether it's negative or positive. I think the most common mistake that students make is on this third one here. It says your LSR line has 2 coefficients. Explain what each one means in the context of this example. That's meant to be similar to this section up here in purple. Here are the 2 coefficients that I'm talking about, the numbers that you see here and here. And then the interpretations are similar to what you see here and here. How many shark attacks would you expect in a month where 20 hot chocolates are sold? This is making predictions. We do that in the classwork as well. I think that's a little higher up if I remember right. Use the LSR line to predict the number of hikers instead of shark attacks when the temperature is 16 instead of hot chocolate sales or 16 or whatever. Finally, the last question. Am I right? Can we conclude that drinking hot chocolate causes less shark attacks? If you don't know what I'm talking about here, note the underlining. Can we determine causation, or can we only determine correlation in a study of this type? That's what I'm getting at in this last question. Anyways, hope that's helpful.